Hello, my name is Davis Binger, and let's talk about trig substitution. Today we will be performing problem 3 of the 7.4 handout, in which we will evaluate the integral of the square root of 1 minus x squared divided by x with respect to x. Let us take a moment to recall the criteria for choosing the appropriate trig substitution. We will let a be a constant and x be a variable. For a given expression, we will identify the substitution and the corresponding trig identity. If we are looking at the expression a squared minus x squared, we will make the trig substitution x equals a sine theta. This arises from the trig identity 1 minus sine squared theta is equal to cosine squared theta. If we have the expression x squared minus a squared, the substitution required is x equals a secant theta. Based on the trig identity, secant squared theta minus 1 is equal to tan squared theta. Finally, if our expression is x squared plus a squared, our substitution will be x equals a tangent theta based on the identity tangent squared theta plus 1 is equal to secant squared theta. In our case, we would like to make a trig substitution to resolve the square root of 1 minus x squared. Thus we are of the form a squared minus x squared, and a is equal to 1. So our substitution we will make is x equals sine theta, and dx equals cosine theta d theta. Thus, our integral is equal to the integral of the square root of 1 minus sine squared theta divided by sine theta cosine theta d theta. We apply the identity 1 minus sine squared theta is equal to cosine squared theta, and we arrive at the integral of the square root of cosine squared theta divided by sine theta times cosine theta d theta. Now, as I've said before, when you have a quantity squared and then you take the square root, you must be especially careful. Only when this quantity is positive can you cancel the square and the square root. And in this case, one is concerned because we've all seen the graph of cosine theta and know that it takes on negative values. But we are able to resolve this square root in this case because of the following reason. Recall that we set x equal to sine theta. Now let's think about the values x can take for this particular function. We need 1 minus x squared to be a positive number. If x is larger than 1, then 1 minus x squared is a negative number. So we know that x is between negative 1 and 1. As such, we can find a value of theta. We can choose the theta to be between negative pi over 2 and pi over 2. On this interval, cosine squared theta is positive. Now, let me make a general comment about trig substitution. You generally don't need to worry about this subtlety of the square root of quantity squared in the case that you're substituting for sine theta and tangent theta. A similar argument to what I just made will allow you to simplify the radical as your intuition tells you. But subtleties arise when you make the substitution x equals secant theta. This is because for various choices of theta, the function is positive, and other choices of theta, the function is negative. If you have any questions about these subtleties, I will be happy to go over them with you in greater details over email. So please email me at binger@math.ohio-state.edu or leave a comment below. Returning to the problem at hand, we can resolve the square root of cosine squared theta. And we get that the integral of cosine squared theta divided by sine theta d theta. Now we need to apply the techniques of Chapter 7, Section 3, trig integration. We inspect the integral, and we see that the cosine squared theta appears in the numerator with an even power. Thus, the technique of u substitution in this case won't work. We will need a more creative response. The correct line of thinking will be to make the substitution for cosine squared theta 1 minus sine squared theta. We can then decompose this fraction into two fractions, 1 over sine theta minus sine squared over sine theta. 1 over sine theta is exactly cosecant theta, and sine squared theta divided by sine theta is sine theta. We know the antiderivative of cosecant theta and sine theta. Hence, we can integrate, and we get negative log cosecant theta plus cotangent theta plus cosine theta plus c. Thus, to finish, we need to identify what cosecant theta, cotangent theta, and cosine are in terms of x. We need to substitute back into our original variable. To do this, we construct the following reference triangle. We know that x is equal to sine theta. So if we construct a right triangle, and we will let this angle here be theta, then the opposite edge is x, and the hypotenuse is 1. Then, using the Pythagorean theorem, the adjacent leg can be found to be 1 minus x squared to the 1/2. That is the square root of 1 minus x squared. Hence, we can use our SOHCAHTOA method to identify the unknown trig functions. Cosine theta is adjacent over hypotenuse. Hence, it is the square root of 1 minus x squared over 1, or just the square root of 1 minus x squared. Cosecant theta is hypotenuse over opposite, or 1 over x. And cotangent is adjacent over opposite, or the square root of 1 minus x squared over x. We can then plug these in to the antiderivative we found in terms of cosine theta, cotangent theta, and cosecant theta to arrive at our final solution. Thank you for watching, and as always, you can reach me by email at binger@math.ohio-state.edu, or you can leave a comment below. Have a good evening.